Let's prove the quadratic formula. The method what we need is completing a square. Let's practice the idea by using an example. If we would have a equal to 1 and c equal to minus d, our equation would take this form. Now we could draw some geometric shapes. If we have a square with sides x and x, the area will be x squared. If we have a rectangle with side length x and another side length b, it would have the area bx. Together these areas should be equal to some area d. Now, if we would have to find the length x, we could do in this way. We could divide the rectangle into two pieces, and we could move the two pieces next to the square. We see that there's one piece missing here. If we would add that missing piece to both sides of the equation, in the left hand side we would have a complete square, the rectangle is gone because we just shifted the parts, and in the right hand side we would have some constant. Now, if we would proceed in this geometric way, we could find the total constant in the right hand side by using some method. And we would see that this side length here should be equal to the total side length here. This should be the geometric idea, main point being that we are completing the square by dividing the rectangle into two pieces and adding one missing piece. Let's see this process as an example. Through an example. We considered this equation recently. Let's shift the minus 2 to other side. We would want to write the left hand side as a complete square. It means that we would have some p plus q to power 2. Well, we can expand this formula and we would get something like this. So we should make the left hand side to look the same as this formula here. Well, our p could be x, and now we just need to find q. What is q? Well, let's start to transform the left hand side. There we have x squared, and next we need to arrange that we have a plus 2 there. Well, the way to do this is we need to compensate for that. Now, if we have both 2 and 1/2 here, then everything is okay. So now already we have these first two pieces which are fine there. And we see that our q would be equal to 1/2. Let's add this missing piece q squared to the both sides. And we will get something like this. Now we can write the left hand side as x plus 1/2 to power 2, and we can simplify the right hand side to be 9/4. Now that we have the complete square on the left, we can take square roots on both sides, and we get that, well, you need to be careful with the square roots. You can add plus and minus signs there, because, for example, 2 to power 2 is 4, but also minus 2 to power 2 is 4. So you can't really know that do you have a minus sign or a plus sign. Well, let's take the square root on both sides. We get that x plus 1/2 is plus or minus square root of 9/4. We can take the square root separately from 9 and 4, and we get 3/2. So in the end we have that x is minus 1/2 plus 3/2, which would give 1, or x is equal to minus 1/2 minus 3/2, what would give minus 2. In this way we would get the solutions. If we would take this step what we just got and move 9/4 to the left hand side, we could express the original polynomial in this way. From this we could see that because the square is always non-negative, the minimum value of this left hand side is equal to minus 9/4, and we would attain this value when x plus 1 is 0, that means when x is minus 1/2. We saw these things in another video. Namely, if we would draw a graph of this polynomial, it would look like this. It's a parabola here, and the minimum value is attained when x is minus 1/2, and it is equal to minus 9/4. Now let's prove the general formula in the same way. Let's start from the original equation and divide by a. And let's be smart and still move c/a to the right hand side. It comes minus c/a, like this. We should make the left hand side to look like this expression. We can arrange a number 2 there by both multiplying and dividing by 2. Now the first two terms are fine, and we need to add on both sides the term q squared. Well, our q seems to be now equal to b/2a, so we can add the square of that to both sides. Next we can do some simplifications. In the left hand side we can write everything as a square, and in the right hand side we can calculate. Well, we have minus c/a plus b squared over 4a squared, and let's write the first fraction in this form. 4ac over 4a squared. When we do that, we can combine the fractions because they have a common denominator. And we would get b squared minus 4ac divided by 4a squared. Now everything is simplified and we can take the square root on both sides. And let's remember to add the plus minus there. We get that x plus b over 2a is equal to, we can take the square root separately in the numerator. And separately in the denominator. In the denominator we can get 2a. We have the plus and minus signs here, so no problem. We have dealt with that fact. And now the last step is to shift this term to the right hand side. Well, what we get then, x is equal to minus b plus minus square root b squared minus 4ac divided by 2a. We were able to prove our formula.